Hello, this is Nick Bertozzi. On behalf of the teaching team, I'd like to welcome you to RBE 2001. Class will be starting in a couple of days, and thought you might want to get started on a couple of things if you have time. So, on the syllabus is available, so you can go ahead and read that. And there's a Google Calendar, so this will be populated with the office hours for the SAs and TAs and myself. And also you can see that there are already some FC, that stands for Flipped Classroom, so there's some quizzes that you can get started on. The first 5 of them are just going to be on Solidworks, so there's some video describes how to take those quizzes a little bit later in this video. So, but anyways, if you have time and you want to get started on that, then you can go ahead. Okay, so you can just go ahead and click on modules and look at some of the things available here. There's actually a SolidWorks model of the field that you can look at. But mainly I want you to just work on some of the SolidWorks stuff. This will explain how you can either load SolidWorks onto your own computer or use this frame VDI for SolidWorks, and that will be explained in just a second. You can go to remote desktop, or MathCAD you can actually go to the software store, and as long as you're on campus or have the VPN on, you can use that. You can use MathCAD. You can install it on your own computer and use it on your own computer. So using it with remote desktop is pretty easy as well. Now for SolidWorks, you can either use the frame VDI, or you can download it you can install it on your own computer, or you can go to there's different computers on campus that have it. For instance, in Higgins Labs, I think it's HL230 is a large computer lab. A lot of times there's classes going on in there, but I think they'll have the schedule posted at some point, and so that you can use that. Also, the Innovation Studio Lab 103, we've asked IT to install SolidWorks and MathCAD and MATLAB on those computers. I just got an email from them that they had to remove 4 of the computers and take them back to work on. They were trying to install SolidWorks and they were having a problem with it. But anyways, that should be available there as well. So if you have a good computer, especially if you have a good graphics card and enough RAM, then you might want to install it on your own computer. And so there's links here how to do that. Right, you have to go to this drive right here, the storage drive, and I found that it takes a really long time. I think you want to make sure you're on campus when you try and download this. It takes a long time to download it. As I said, you want to make sure you have a good computer, and then there's also the serial number that you have to put in. So on the other hand, you can use this frame VDI, and I have a video that explains how to use that with OneDrive. So right back here, so this takes you to, I'll just click on that, see, so that you just have to click on that and then go to access frame VDI. But the problem is, and this is a really good computer, remote computer that works really well with SolidWorks. The problem though is that when you log out, you lose anything that's on the drive of that computer itself. So you can download stuff and then re-upload it back to your OneDrive or whatever separately, but it's kind of a hassle, especially in SolidWorks. When you create an assembly, each part has its own file, so you don't just import or download the assembly file. You have to get all the part files, and if you have drawings, you have to get all those as well. So the best thing is to just use it with your OneDrive, and it's a little bit it's somewhat complicated to get that set up, and it takes a few minutes. So every time you use the frame VDI, you'll have to connect with your OneDrive. But the beauty of that is, then you open the files right from your OneDrive, and when you save them, everything is saved to your OneDrive. You don't have to like upload or download anything else. So this is a video. It's 10 minutes long, and students always tell me that you can watch my videos at least 1.5 speed. So you don't. It's less than 10 minutes then. But anyways, in terms of using SolidWorks, it's Frame VDI, or you can install it on your computer, or you can find a computer on campus. Okay, so that's this information here, and okay, and then there's this link to additional materials. So for the quizzes, you want to go to the playlist for SolidWorks. I'm also including these files, so these aren't links to YouTube videos. These are actual format files and template files, which you can use. You don't have to use them. And so if you download them and then just change the name, because obviously like the format files for drawings or have my name in them, you want to change your name. And I also find it useful when you're saving files like this, these are the template files or the format files, is to put your initials in front so that you don't, sometimes if you're on a particular desktop, say in the lab, and you create a template, you might inadvertently save it to the hard drive on that machine, and then you're not, when you go to use a different computer, you're not going to have access to it. So I always like to put initials in front of my template files so that I can be sure, when I go to open them in SolidWorks and I see the NB, in this case, I know that it's I have the right template. So anyways, for the SolidWorks quizzes, what you'll first do is watch the videos, right? I'm going to update the welcome video here. So in other words, like for the first quiz, if I go back to assignments, right, so for that first quiz, it says watch from that playlist, basically video A and video B. They're each about 5 minutes long, so it looks like there's a lot of them. But what you want to do is watch them, and it's good if you have two computers, right, or at least two screens. So you can watch the video and then open up SolidWorks and try the stuff that was done in the video. And we are going to be using SolidWorks. You'll have to model your whole robot in SolidWorks and actually be able to do some analysis on it too, like you'll do motion studies to determine how much torque you need in your 4-bar mechanism, things like that. And you'll need to have bill of materials and exploded assembly views and things. So this is all stuff that you're going to use for the project. Anyways, the first quiz you actually have 2 attempts, the other ones you don't, just to kind of get you up to speed. So you'll have 2 attempts, and when you're trying to go through the videos or whatever and learn SolidWorks, you can work with somebody else. But when you take the quiz, it has to be your own answer. And by the way, the quiz will, after you take the quiz, you'll be able to see the correct answers, which ones you got wrong and what the correct answers were. So you're on your honor not to work with somebody else and maybe take turns seeing what the right answers are and then passing on the right answers. No, integrity is your most important attribute as a professional engineer. So I'm expecting you to only answer the questions based on your own understanding, not finding out what the answers are from somebody else. So anyways, for each of these quizzes, you just, like if I look at the second one, it says watch C, D, E, and F, and then take that quiz. And then in the same way, you'll watch when you do the MathCAD, right, it says make sure you do the playlist up through these 3 right here, right? So if I go back to modules and right, if I scroll down, right, MathCAD introduction playlist. So on this one, you want to make sure you watch down through the force analysis 1, 2, and 3 before you take that quiz. So again, we are going to push pretty hard in the beginning of the term because we want to get through a lot of material so that you can, work on your project. It's kind of tricky. It's a 7-week term, and you need lots of time to work on your project. So we want to try and get through a lot of material up front so that you'll be ready to do a good job on your project. But anyways. All right, and there's other material here that is useful. There's an introduction to object-oriented programming that I had some students do. There's this playlist for C programming. And this is a really nice play. It's a step-by-step right from the beginning of learning C programming. So you can look at that if you want to brush up, or if you want to, if you're not, if coding isn't your strength, you might want to look at that. There's a force analysis playlist here. So if I click on that, and this is just from Professor Stafford. So you probably have already watched this playlist in RBE 1001, but we're going to do a lot of stuff with force analysis. So if you want to review that, you can do that. Okay, and let's go to modules again. So there's also some lectures here from Ken Stafford on force analysis, so you can use those as review if you want to. Under lab information right now, if you have to do any soldering, this is a great video that Kevin did. If you're rusty on using an oscilloscope, this is a really good primer. In this one, it also has some videos on using the Tektronix oscilloscope, and we also have a video on using the function generator. So these are videos that you can watch and review how to use some of the equipment. Okay, and before I forget, I know that some of you are already pretty expert at using Solidworks, so you might find the quiz is fairly easy. If you've never used SolidWorks before, you might want to just start out with the SolidWorks tutorials found here. Just open up SolidWorks and click on Help, and then Tutorials. Okay, and then there's these 3 lessons: Lesson 1, Parts; Lesson 2, Assemblies; Lesson 3, Drawings. So you can click on those, and it takes you through step by step how to create parts. And let's see, I'll just do one more. So in these little things that are highlighted here, like if you click on it, it shows you, right? I just clicked on Zoom to fit there, and it highlights up here. So they're tutorials that are pretty easy to use. And if you've never used SolidWorks before, again, I would recommend that you do Lesson 1, Lesson 2, Lesson 3, and then start the playlist that I pointed out. Okay, just a couple more things to point out. We will be shooting to have teams of 4, and each team will build at least 2 robots, and we're going to be using the 32U4 board. And so if you already have a group of 4 students that your schedules work out and you want to work together, then you can go ahead and just find a team that doesn't have anybody in it, and then the 4 of you can just add yourselves into that team. The restriction, of course, is that you have to be in the same section. But again, if you want to contact some people and see if you want to form a team, then that's fine. And then just the other thing, going back to okay, so under the final project, there's the description of the final project file that's ready for you to look at. You can download this zip folder right here and do an extract all, and that has a SolidWorks assembly of the field. So let me just show you that. Right, so that's what's going to be in there. So you have an aluminum plate and the materials acrylic's actually just 3D printed, but and then you have a solid model of the Romy base. So this is what you'll be building on top of, and these are the staging blocks right here. So anyways, you have that, and there's some sample models here that we'll be looking at. They're not the right size for what you need to do, but they're just some models to look at. And then under this section right here, there's a bunch of parts that you might want to use, okay? Including a complete bottom-out gripper. So that's a gripper with a lower jaw that just pivots down. And also a complete model of a gripper that uses a lead screw, including a video that explains the code on how to use it. So the idea here is that you can just go ahead and use these models. The only thing you'd need to change is just the location of the joints. In other words, you're going to design a 4-bar, and you're going to have to figure out where the joint should go on those grippers. But other than that, these are complete functioning grippers that you can just print out the parts if you want to. You get extra credit points if you design your own grippers from scratch. But we wanted to give you the option of just go ahead and using these that are already they're already set up. So if I look at the Solidworks, let's see. Okay, so here's the one with the lead screw, which is actually just an M5. So it uses M5. It sits in a bearing. This is a continuous rotation servo, and then there's a linear potentiometer here, so that you can determine where the jaw is. That's actually, it fits in a hole right down here, and these are all 3D printed parts. So you can just go ahead and print this and build it, and if you want to. Okay, so I think that's about it for now. Again, we're really looking forward to working with you this term. This is a very intense course, so if you can make progress on your SolidWorks, especially if you haven't used SolidWorks before, there's lots of YouTube videos out there in addition to the videos that we've already made. But as a roboticist, it's important that you know your way around a little bit on using a solid modeler, and we'll be doing some motion studies, plotting torque, and so in other words, once you have the model, there's a lot that you can do with it. Anyways, we look forward to seeing you soon.